Enjoy your next 24 hours.
Your microphone on?
We can hear you, Martin.
I was just talking to my little boy, Dad. Sorry about that, everyone.
All right. Well, good afternoon, everybody, and welcome along to Data Platform Downunder for the month of July. My name's Warwick Rudd. Along with my co-host, Martin Catherall, we're happy to bring you Torsten Strauss, who's going to be taking us through the next hour on Next-Gen AI Insights, Native Vector Search in SQL Server 2025. Before I do hand over to Torsten to take us through this session, just want to let everybody know on the call that this session is being recorded, and we will make a decision about placing it up onto the YouTube channel after this. If you haven't already joined the Data Platform Downunder YouTube channel, I will look at putting that link into the chat where you can come back and watch all of the sessions that we have hosted. If you do have any questions throughout the session, make sure that you put them in the chat window. I will be looking at those, so I'll be able to make sure that those questions get to Torsten appropriately. So with that, we'll get today's session underway, and I'll hand over to Torsten.
Great. Let me try to share my screen. I hope you can see my screen.
Yes.
Okay, let me introduce myself. I think it is the first time that I'm speaking at this media group. Yes, because otherwise I would remember, because it's very early my time. It's 4:30 a.m. Yeah, so let me introduce myself. So my name is Torsten Strauss. I'm a consultant, trainer, and speaker. Yeah, maybe the most important one is my email address, which you can see here. So in case of any questions with regards to, yeah, let's say Azure SQL, in-common, performance tuning, Azure DevOps, or maybe about the session, feel free to reach out to me, and I will try to answer. I cannot promise what, but I will do my best. So let me close this one. Okay, so yes, so as already mentioned, so I'm going to demonstrate how vector search in Azure SQL 2025 is working. So this was a feature which was introduced already in Azure SQL database. I don't know when, but now it's fully available in on-prem, so which means SQL Server 2025. I think it was HTTP 1.3 or 1.4. I don't remember anymore, but it's definitely available when you download the latest version. And yes, it's about all the other way around. Vector search has a lot of benefits. Maybe I have an example later, but maybe full text search, which some of you might using. But vector search is a complete different story, and I was thinking about use cases before I decided to start working on vector search in order to understand the internals. So, and I asked ChatGPT about use cases, and you can see quite a lot of use cases here. So the first one is you think about you are selling some electronic devices, and someone is searching your website for fast laptops. And the problem here is this user is searching for any kind of meaning. So it is about laptop, but it is also about fast laptop. So the problem here is that it's something which you cannot do with full text search, because usually what you do with full text search is you're using full text search to search for a term. So you can say a word nearby another word. Yeah? So that is something which you can do with full text search, but you cannot search for a meaning of a sentence. So fast laptop can be, when you search for fast laptop, you can search for, I don't know, good laptop or very fast or whatever. So the problem here is that you don't have an exact search. You're searching for meaning instead. So this is a complete different idea now. So, and for sure, what you can or what you will get back is maybe you have some, I don't know, some reviews from other customers, and now you are searching within the reviews for fast laptops. Yeah? So that is the idea here, which is completely different than full text search. We will see later that you can combine full text search with vector search in order to get the full power. Sometimes it makes sense, or often it makes sense. Yeah, let's try to focus on vector search first. So another use case is maybe, I don't know, you have a small chatbot or whatever, and the user is asking for how to reset my password. So, and now you have, I don't know, a bunch of PDF documents, and vector searches are able to scan the vectors, the PDF documents within your library, and will find all documents which are related to how to reset a password. So that is something which will work. And another one, for example, is you're a lawyer, and you're looking for specific I don't know, terms or conditions or whatever, and now you can use your vector search to find any kind of related contracts or whatever. And another one which we will go to, or which I will show, is customer review analysis. So it means you can imagine you have a lot of reviews available by different or in different platforms like Amazon or whatever, and now you're looking for or you want to evaluate the reviews in order to get a feeling about if this is a positive or negative review. That is something which you can do with vector search as well. So, and the good thing about vector search is that it is fully dependent on OpenAI. It means you have the full power of Azure, and now you connect your Azure SQL database or Azure SQL on-prem to the OpenAI search engine in order to do the magic. Yeah? So we will go into the code later on. But first of all, I guess it is a good idea to understand what a vector is. So you can see that a vector is nothing else than arrays of numbers. So these are typically floats, and we will see the internals. It's definitely a float used to represent a structure in a numeric form. So that means when you have an image or whatever, or you have a text. So what happens is that the OpenAI search engine will now, let's go to the text, right? So it will analyze the text. So that means you have a sentence, and it will break down the sentence into words. So that is something what the full text search engine is doing as well. But OpenAI goes one step further. It will take the words and but it will keep the meaning. So that means you don't have, or the result is not just a chain of words. It is the meaning of the sentence, which is completely different to full text search. So, and what you will get back is a vector, which is nothing else than, let's say, a numerical array representing the meaning and all the words within the sentence. So that will give you two options. You can search for words within the sentence, and you can search for the meaning of the sentence. So again, this is completely different to full text search. So that means when you get back the vector, which is nothing else than an array of float, that is called an embedding. So here's an example to judge whether a person is healthy or not. So you have, I don't know, an embedding which is, or in the meaning of height, the weight, the age, the blood pressure, and the heart rate. And just having these kind of, I would say, numbers will give you nothing, right? But the combination of all the numbers, of all the, let's say, the metrics here, will give you an embedding. And that means you can now go through all the vectors and compare them by the meaning of the vector. And you will get back, let's say, an impression whether the person is healthy or not. So, and again, when you use OpenAI in order to get back the vector, you will get back the embedding. So the embedding is nothing else than the vector, which includes the meaning. So this is different to the vector, right? The embedding is already, I would say, the result of the OpenAI search engine, keeping the meaning of the sentence or the words or whatever. So as already mentioned, so first of all, when you have a sentence, so that there's a token embedding, which means every single word within the sentence is an embedding. But again, you will also get something back, which is the sentence or the document embedding, which is a single vector representing the entire sentence, keeping the meaning of the sentence. So how does it work? So vector search is, again, the process of finding an item in a data set. Both embedding are similar to a given query embedding. Means when you go back to the reviews, when you're searching for, I don't know, a very good restaurant nearby. So what happens is that you have a database, and for every single review, you have the result of your OpenAI search engine or vector engine. That means every single review have an embedding, which is a result of the OpenAI vector search engine. So and now the user is asking for a very good restaurant nearby. That means the term very good restaurant, which you are searching for, is also going through the vector OpenAI search engine. It means your sentence is also finally an embedding. And now you can compare the embedding with different algorithms in order to find very similar reviews or reviews which will meet your question. So we have three different kind of, let's say, a vector search or algorithms. So we have the Cosin similarity. That is something which we will use because this is the most common for, let's say, text analysis. Then we have the Euclidean distance, and we have the dot product. So, and again, the closer the two vectors are, that means the vector you're searching for and the vector you will look for into your database, the closer these kind of vectors are, the closer the embeddings are, the more similar they are. So that is the idea. It means you're not looking for a specific word or whatever, you compare the vector embeddings finally. So you can see, for example, I don't want to go into the formula, so you will find a lot of articles in Wikipedia or whatever, which definitely describe how this kind of algorithm works. But you can imagine when you have a vector which is a human and you have another vector which is person, when you use your vector, when you use your full text search engine, you will not find any hit here. So that means person is not similar to human. But when you use a vector embedding, finally, the OpenAI search engine is capable to find the meaning of both words, and you get something back which is something between 0 and 1. So that means the closer, and here the closer means close to 1, the closer these words are, the more similarity you have. So we will see it later on. So we have two other search engine algorithms, as already mentioned. I don't want to go into detail here because we are not using them. Instead, I will show you how it works. So first of all, what you have to understand is that we have a new data type in SQL Server 2025, and for sure in Azure SQL database, which is called the vector data type. So you can see how it works. You define a column, and then you have a data type, which is called vector, and then you have a dimension. The dimension is something which is dependent on the algorithm you use, and within the algorithm, you can, let's say, you can set how many vectors, how many embeddings you're getting back. That is called the number of dimensions. So a different, let's say, when you go to the OpenAI search engine later on, you will see that we have something which is a text small OpenAI search engine, which will give you back, I think, 1,512 or whatever dimensions. That means you have to align the number of dimensions with a search engine or with a search algorithm you're using, because it has to fit into the data type for sure. So yes, so we will see that the array is an internal representation, or the vector type is nothing else than an internal representation of an array of floats. So that means every single item within the embedding is 4 byte long. So that is not true. I mean, I understand that every single float will allocate 4 bytes, but sometimes it is very interesting to understand how many bytes a record will allocate, right? Because you have to understand the storage allocation, which is growing for sure when you keep more and more records into your database and you have a vector data type. So let me go down. So first of all, what we will do here is, and I will go back to the section later on, but first of all, I want to cover the storage allocation of a vector data type. So what we are going, or what I already did, I don't want to run the example another time, but you can see that we have a database here, which is called vectors. And within the vector database, I just create a schema vectors. So next, I'm going to create a table. And the table is named vector data type. And you can see it's a very, very simple table. We have just an ID. And we have a column which has a vector type of 1. So that means this is the smallest possible vector type in terms of size. We have just 1 dimension. So now I'm inserting 1 record into the table, and you can see this is a representation of a float within an array. That means when you want to insert the records into a data type, or in this case, a vector data type, you have to use the square brackets. Okay, when you now ask about the page allocation, you know that whenever you save or whenever you create a table and you save any kind of a record into the table, you have page allocation. So page is 8 kilobyte. It has a header, it has a payload, and it has a row offset array. So, and now it's interesting to understand the storage allocation. So let's try to run it. And I just want to make sure that I think I still have the same page, but I need to figure it out. Let's try to run it. I cannot, so the page number is changing over time. So that is a reason why I cannot guarantee that the page is still correct, but it is. So you can see this is the page. That means after inserting the record into the table, SQL Server will allocate an 8 kilobyte page within your memory and finally with on the disk. And you can see that this is the internal representation of the vector data type. Let me go up, and I will share the example with you for sure. So what you can see here is interesting. So usually you have something which is called a fixed variable format. This is the, let's say, the format which is internally used by SQL Server to store data. when you don't have any kind of compression or you use, I don't know, memory OTP or column store indexes. That means whenever you have a default table, the fixed variable format is something SQL Server will use. That means you have something like a tag A, a tag B, then you have the F size, which is the size of the record, then you have the F data, which is a fixed data type, or in this case, the vector data type. Or it is not the vector type, sorry, it is something, in our case, this is the integer, because the integer is the fixed data type. Then you have the number of columns with 2 bytes, and then you have null bit to indicate whether you have null record or not within the fixed data type, let's say portion of the record. And then you have the vector data type. In this case, you can see we have 12 bytes. This is not what I expected, because when you go into the documentation, you will see that Microsoft describes the vector search, or the vector data type with 4 bytes. That is not true. You have another, let's say, overhead for every single vector data type within the page of 8 kilobyte. That means when you now have a vector type of 2 dimensions, the storage allocation will be 8 byte as an overhead, plus 4 byte for the first, and another 4 byte for the second dimension. I mean, it's good to know. It's not very important, but sometimes you have to understand the storage allocation and for sure your memory allocation, because finally you will load all the pages from disk into buffer. So therefore, it is good, at least good to know how much space is finally allocated by a vector data type. So let me go up now, because I want to go back to the limitations. So the vector data type has some limitations, as you can see here, and something which we will see later is this is for me the most important one. When you want to index the vector data type, this is something which you can do, but then the index or the table itself is read-only. You remember the time where we had column store indexes. At that point in time, column store index were read-only. Now, for sure, with the tuple mover and the delta and the bitmap and everything which was introduced by Microsoft later on, will give you the possibility to write to a column store index internally. It is nothing else than a B tree. And again, then the tuple mover will compress all the records within your, let's say, delta store to a new column segment. So that means I'm pretty sure that Microsoft will introduce, let's say, writable vector indexes later. I don't know when, but I'm pretty sure this will happen. But at that point in time, when you index your vector search or your vector data type, this is read-only, which is for sure a big limitation, because you can imagine what happens when you insert new records into the table. First of all, you have to drop the index, and then you have to insert the new vector embeddings into your table, and finally you have to re-index or rebuild your index. Right, so this is for me the most or the biggest limitation. Okay, so vector data types do not have any kind of column level constraints. That means you cannot set a default, or you cannot, I don't know, a check constraint or whatever. That's something you cannot introduce. Is this important or any kind of limitation? I would say no, because does it really make sense to have the default for vector data type? Even the default of 0 is already an interpretation and is an embedding, because 0 is not comparable to null. That means for me, it makes no sense to have any kind of default or whatever available. So I don't think it is a limitation. So you cannot have any kind of key constraints like a primary key or foreign key on a vector data type or a column. So, and for sure, you cannot create any kind of unique constraint. Again, is this something you should worry about? I would say no, because it doesn't make sense. You don't want to have a primary key on embedding on a vector data type and a foreign key. It doesn't make sense. So therefore, I would say it is good to know, but it is not a limitation. Yeah, so changing the range of the, let's say, the dimensions is something which is not supported at that point in time. That means when you have, when you decide for, you decide the number of dimensions you need, you cannot change it later on. For sure, you can insert the records into a new table with a new vector data type with a new dimension or number of dimensions that will work, but you cannot do it by altering the table or altering the column. Yeah, again, it's not a limitation for me. Maybe a limitation is you cannot use vector data type within in-memory OLTP tables. That is maybe some kind of limitation because in-memory OLTP is definitely a very nice feature, very fast. And some of my customers are using in-memory OLTP. And this is the limitation. You cannot use vector embeddings or the vector data type in conjunction with in-memory OLTP. BCP and bulk insert is currently not working. That means you cannot bulk insert records from, I don't know, from a text document which you have in your block container or whatever. That is not supported. And column encryption is not supported. Yeah. So maybe this is some kind of limitation for some customers. So, and again, keep in mind that even though we have an array of floats and every single float has just 4 bytes, you have an overhead for every single record within your vector data type of 8 bytes. So that is something you should know. Let me scroll down. Here we go. So in SQL Server 2025 and in Azure SQL Database, we have currently we have 3 vector functions. The first one is the vector distance, which will calculate the distance between 2 vectors using a specific distance metric. So that is something which we will see here. So, and for sure the distance metric are these available algorithms like Cousin, Euclidean, and Dot. So that means you can decide which kind of distance you want to take into consideration when you ask yourself the question, how close the embeddings are. So the second vector function is the vector norm that takes a vector as an import and return its norm. So to be honest, I don't have any example here. I don't even know how to use the function. Maybe there are some use cases, go into the documentation, and I'm pretty sure when you use or when you read the documentation, maybe there's a use case for you. Also, vector normalize is something I don't have any example, but again, go into the documentation, read the documentation, maybe that is something you will use. Okay, so let's go into the vector distance because this is the most important function as mentioned. So we within the function we have to define the distance metric. And again, these are the algorithms which we know already, Cousin, Euclidean, and Dot. So let's go down. So what you can see here is someone waiting in the lobby. So we have to understand the difference between the distance and the so-called similarity. So you can see that the vector function, which is our vector distance function, will return the distance because this is the name of the function. So the distance is something between 0 and 2. So you can for sure calculate the similarity, which you often use in order to compare two embeddings, by easily use this function. So that means when you have a distance of 0, the similarity is 1. When you have a distance of 1, the similarity is 0. And the distance of 2 will have a similarity of -1. So again, the interpretation is for sure the same. So is just another interpretation of the number of the result. So we have either distance or similarity. So it depends what you will use. So what is Open or Azure OpenAI Service? So it is a cloud-based platform that provide access to OpenAI powerful language models, such as GPT, Codex, and embedding models. That is something which we will use. So, for example, we will use Seach small embedding. So, and it is nothing else than a REST API, which you can use. So that means the entire, let's say, all the resources, and we will go into detail, are completely hosted by the Azure environment. That means when you want to use or when you want to calculate the embeddings, so that means when you want to use the vector search engine, you have to be online because otherwise it is not working, which is usually not a problem when you have an Azure VM or whatever, or an Azure SQL database, because then you are already in the Azure, let's say, ecosystem. But when you have an on-premise server in your, I don't know, data center or whatever, you have to ensure that, or you have to consider that you have network in between. That means you will call a REST API for every single vector search engine, vector engine search, or when you insert new records into the table, you will call a REST API to get the embedding. That has for sure a performance impact, right? Because first of all, you have a REST API, which is again network, and then on the other end, you have the OpenAI search engine, and dependent on the power, the result, or to calculate the embedding, it will take time. Right, that is something you have to consider. That means OpenAI search is definitely a nice feature, but I would say it is nothing you want to introduce in an OTP workload. So, as mentioned, there are different embedding models, and one of the model is called a text embedding, and I think it should work. Yes. So that is the first time that we are using, or I will open the OpenAI search engine within Azure. So you can see how it works. You can either, so what I tried, and that was, I would say it was difficult. I was trying to create a bicep template in order to get all the resources within my Azure resource group, which are required for the OpenAI search engine. Finally, it was too complicated for me, so I decided not to put it into my documentation. I'm pretty sure it will work finally, but it took too much time. So, but anyway, you can for sure do it within the Azure UI. So that means you go into the portal and just create an OpenAI search engine, and that is the result. That means you have a lot of, let's say, features and options available, but the most important one is your endpoint. So that is the endpoint which you need, because again, the OpenAI search engine is nothing else than a REST API. That means SQL Server have to communicate with the open search engine, and that is by the endpoint. So let me go into the code another time. So in order to get the endpoint, because usually that is something you want to automate, you can run a script like this. So you pass the subscription ID, the tenant ID, and the cognitive service account, and finally you will get back an endpoint. That is the endpoint, and then you have a so-called API key. That is a secret, so something you should keep in secret, because with the OpenAI search engine, with the endpoint and the API key, you can finally use your OpenAI search engine. It means everyone who has the OpenAI endpoint and the API key can use your open search engine. So with this in mind, what you have to do is you have to create a database scope credential on the database. So the idea is the following. First of all, you have to create a so-called master key. The master key is something which you will create within your database that will encrypt every single secret within your database. So when you have when the master key is in place, I mean, this is definitely not a very strong password here, but it is working. You can create a database scope credential. And the database scope credential, you can see it here, is nothing else than the identity and the secret. The identity is our HTTP endpoint, and the secret is the API key. That means no one has to use or even have to know the API key when you have a database scope credential in place, which is completely secured by the master key, because the master key will encrypt the API key. And the good thing is for sure that the API key, so the database scope credential, is part of your backup. That means when something is broken, you have to restore your database, the API key, the database scope credential will be restored when you have your master key in place. So let me run this because I don't want to execute the entire script. Just want to make sure that we have the right database scope credential in place. Takes a moment. Sorry. Yeah, this should work. Cool. So we can see that the database scope credential as well as the master key is in place. So we can see the credential identity is our HTTP endpoint header, so which we will now use within our REST API call from SQL Server. Go back. Yes, so when you now want to call a REST API from SQL Server, there's a new advanced option available in SQL Server 2025, which is called External REST Endpoint Enabled, because for sure it has some kind of security impact. Right? You have to make sure that you can use REST API within SQL Server. That is an advanced option. So let me run this. Oops. I can run it from the notebook, or I can run it from here. Execute. So now SQL Server can use REST API. That means the communication to the OpenAI search engine will work. Home. So now it becomes a little bit tricky, and to be honest, it took really a while in order to figure out how it works. So there is a documentation, but for whatever reason, finally it wasn't working for me. So that is the reason why I want to copy the script, and I will explain how it works. Let me go back to Management Studio. So the idea is now the following. We want to create a procedure, and you can see the procedure have just two input parameters and one output parameter. The output is the embedding. You know already what an embedding is. It is nothing else than the result of the OpenAI search engine, which is a vector data type, and the number of dimensions is dependent on the OpenAI search algorithm you select. So now we have two input parameters. We have the deployment name or the deployment model name, and we have the input text. Deployment model name is something which we will find within the OpenAI search engine. Here it is. That is the name of the deployment, which is called text embedding 3 small. So that is something you will get when you set up your OpenAI search engine. So and now we have another parameter which is called the input text, which is nothing else than a varchar max. That means we can pass a word, we can pass a sentence to the OpenAI search engine. So how does it work? So first of all, we have to use, let's say, concatenate the URL, which is nothing else than our endpoint and the deployment model. That is something which you have to use, because otherwise the REST API will not go through or to the right target. So now we call the REST API, the endpoint which we define, with a credential which we created. You remember that we have the database scope credential, and that is nothing else than the API key. That means instead of using the API key, we can now refer to the database scope credential, again, which is fully protected and encrypted by the master key. So, and finally, what we will get back is a JSON. So you know that JSON is fully implemented in SQL Server 2025. And you remember that the data type, the vector data type, is nothing else than an array of floats. So, and therefore, Microsoft decided to use JSON, which is nothing else than an array of, in our case, floats. So, very easy. So, and that means the procedure is now capable to create an embedding for your sentence, for the word or whatever, which you will pass to the OpenAI search engine by using the endpoint and the API key. So I will give you an example. So let me do this. I can run it from here, I can run it from Management Studio. I think that is maybe a little bit better. So, very easy. So we now use the stored procedure. We will pass the deployment name, which is in our case text embedding 3 small. We have an input text, which is human, which is person, and power outlet. And after calling the REST API, we will get the embedding. We do this. I think I need to go to the vector one. Yeah. So you can see how it works. We have a similarity between human and human, which is 1. And you remember that the similarity is something. Let me go back to the document. Similarity is here. So the similarity is something between 1 and -1. And the closer, well, the other way around. When you have a similarity of 1, this is the closest you can get, right? And that is something which we already know. Human is human. That means similarity is 1. So that is nothing else than the highest similarity you can get. So human versus person. So remember, when you now use your full text search engine, you will not get any result back. Here we get a similarity of, what is it, 0.6 or whatever, 0.7. So which means it is already very similar. It's not identical, but it is similar. So now I was trying to, I just want to prove that it is working the other way around. So person versus human has the same similarity, which is good. And then we have human versus power outlet, which has a similarity of 0.1 only. So, and that is the power of the OpenAI search engine. you can now use words, you can now use sentences, and you can compare the similarity. So let me go back to the document. Here we go. Yeah. Correct. So what you can do now is imagine you have already a lot of data in your database and you want to get the vector embedding for every single record. What you can do is you can insert, or let's say when you have the data, when you have the records in the database already, it doesn't make sense to insert the records another time. But imagine we have any kind of text document or whatever, Excel or whatever, we can easily run a BCP command in order to get the records into the database. So that is something which I already did. There's some, let's say, available data set. I think this from Amazon, if I remember correctly, which is called Fine Food Reviews. It doesn't make sense. I think it is not Amazon because it doesn't make sense that we will get reviews about restaurants, but I have no clue. At least there is any kind of sample records you can download. And I inserted all the records into the table. So what you can do now is you can create a table in order to fit the schema or to meet the schema from the inserted data. And you can see we have one column which is called a vector. So in the text embedding, we'll return a dimension of 1536. So what we can do now is the following. Let me copy this. Maybe to here. Here we go. So let's go into the code. So the idea is the following. I have, as mentioned, we have a table here. Let me show you the table. So this is the table. So we have some reviews here. We have some additional metadata available. We have the vector. That means I imported the table into SQL Server, and finally I asked the OpenSearch AI engine to give me the embedding, which is our vector. That means we have a combination of the text and the review and the summary. So it means every single sentence is part of our vector. Okay. So the problem is the following. Well, it's not a problem, but I just want to tell you what I'm going to do. It's this way. It's already here. Sorry, just had to execute this one. So I'm looking for good Thai food within all the records. Again, with a full text search engine, this is not possible. But now what I will get back is nothing else than a vector, an embedding, which is a result of the OpenAI search engine. That means when I copy this, it is nothing else than an array of floats. Here we go. So this is how it looks like. So we have 1536 floats, which is our array. So when I have the embedding for the sentence, or in this case, for the sentence I'm looking for, I can now easily use the vector distance function. In our case, we are using the cuisine algorithm to compare our this embedding, with the embeddings of every single record within the table. So let me execute this one. I think I have to enable statistics and the execution plan. And now let's execute. Declare, sorry, to execute the entire batch. It's working now. So that means I will get back 10 records here. and we can see the distance between the vector text here and our text. It means these records are very close to help me to find good Thai food. Here, for example, you can see I recently moved and couldn't find a Thai restaurant. You can see that when you go through the text, there's a relation between help me to find good Thai restaurants and the text, the review you can see within the table. So let me go to the execution plan. So what we can see here is nothing else than a clustered index scan. A clustered index scan because the table is clustered, but for sure it is not clustered by the vector data type. The problem here is you can already imagine that this doesn't scale. Because when your vector data type is not indexed, the only possibility for SQL Server to find the embedding within the data sets in the vector data type is to scan the entire table. That is for sure a big problem. The more records you have, the more pages SQL Server has to scan, and the longer it will take. And for sure, you can see already the cost allocation here. It is 23. You know, cost is nothing else than a combination of I/O, memory, and CPU. So, and yeah, we have a sort operator here as well. That means SQL Server even needs memory grant. Not a lot, but you can imagine when the table is growing over time, this is nothing which will run very fast. So, yeah, we can now go into the buffer cache. Do it. And within the buffer cache, we can see every single page. It is already grouped by the page, the type of the page, and you can see the number of pages which are cached. That means every single record, every single page, for sure, is finally part of your memory allocation. That means the more records you have to scan, the more pages will go into the memory, into the buffer. That will lead to several performance issues. Page life expectancy and all these kind of other KPIs which are relevant and important. So let's go down. So let me do this. Yeah. Now let's go with this example. Oops. So what you can do is, or what we are trying to do is, we are trying to create non-clustered index on the vector data type, which isn't possible. You remember the limitations. You cannot create an index on a vector data type. That's not possible. But what we can do is we can include the vector data type within a non-clustered index. That means the vector data type will become part of the leaf of the balance tree of our index. So it means we have our index with our key column product ID, and we will include the vector, the summary, and the text. It will take a moment. So I will run a checkpoint dbct drop clean buffer just to make sure that we don't have anything left in our buffer. And now what we can do is the following. We can try to use the index, but for sure it is still not working because we cannot search for the vector. We can only search for the product ID, and within the balance tree of the product ID, we can finally go to the leaf when we identify the product IDs and compare the vector embeddings with every single record which is identified by the product ID. That means when I now go back and I'm looking for something like, where is it? Here, I guess. No, let's go here. I don't find the example anymore. But what we easily can do is we can say where product ID is equal to whatever. So in this case, for sure, SQL Server can use the non-clustered index based on the product ID. So that means the number of records which are finally used within the vector distance function is reduced by the product ID. So that means the more selective the product ID is, the better the vector distance function will work. But this is nothing which will work in reality, right? So we have a problem here. So what we can do now is we can, and sometimes I read the following, or I read a lot of blog articles, and people are trying to convince me to create a column store index on top of the table. So that means the idea is to benefit from the compression. You know that column store index is highly compressed, and for sure we have less memory allocation in our buffer because of the compressed data. But there is no reason to use column store indexes in conjunction with vector data types to get a better performance. That doesn't make sense. It's even the other way around. So when you use your column store indexes, you will figure out that the performance is not better. It's in most of the cases even worse. Yeah? So don't do it. Don't use any kind of column store index in order to boost the query performance. That doesn't make sense. So let me do the following. There are several other examples. Again, I will upload the code later on. I will show you later how to create an index on the vector data type. So now we have a problem, or we have a problem when you have a table and you're inserting a record into the table. How can you get the embedding for the new records or even for the updated records? So the only way to do it is you have to create a trigger. So it works like this. We have a vector table, we create a trigger, and within the trigger, what we are doing is we are just calling the sort procedure, which will now send the text of every single record to the OpenAI search engine and will return a vector embedding. You can imagine that this is definitely something which you don't want to have in an OLTP system because it will completely slow down your system. But if you want to do it automatically, so that means with every single insert, with every single update, the text embedding will be updated by the open search engine. That is the only way to do it. My recommendation is not to use it in an OLTP system. Instead, I don't know, have any kind of nightly job, which automatically updates the embeddings for you for the new records or even for the updated records. It works, but again, it is not very fast. So so the problem about the performance is not just the trigger, but you remember that we have the problem that the vector type is not, it cannot be indexed by the non-clustered, by a non-clustered B tree. So, but what you can do is you can create already a base vector. So in the base vector is nothing else than the embedding. The embedding which you usually search for. So the idea is the following. You can have a table, and I don't know, you have a table of reviews. Let's say, again, you have some kind of restaurant reviews. So and now you're just interested in getting good and bad reviews. That means you can already create an embedding for good review. Because it means you ask OpenAI search engine for the embedding of the sentence, of the meaning of a good review. So when you have the embedding, you can now use the embedding within your table as a constant. And now for every single record, you create an embedding for the new review. And now you can easily compare your constant embedding, which is an indication for either good or bad review, with the new embedding. That means it is much faster because we don't need to use the search engine anymore to compare the values. Instead, you already have one embedding within your trigger. And within the trigger, you can now already compare the similarity between the review and your constant embedding to get the similarity, which is either -1, 0, or 1. So in this case, you get back an integer because it is a similarity or a float. Similarity has decimals, but a float. And a float is something which you can index. And this will give you a much, much better performance. That means by creating a trigger, having a constant embedding you're looking for, and already calculate the similarity between your fixed and constant embedding and the new embeddings for all the new records or the new reviews, again, will return an integer, or not an integer, decimal or float, which can be indexed. So that can be some workaround in order to overcome the problem with non-indexed vector columns. That will work. So let's go down. So is this something I should show? Yeah, maybe I'm just looking for another example, which is maybe even a little bit more important. So therefore, I don't want to run the code. But what you can do is you can create an extended event session. And you can see we have an event on external REST endpoint summary. We have one for vector function usage and another one for vector index build process and the usage of the index. And we will cover vector index in a minute. So again, I don't want to execute the example. I will share the code with you. But Microsoft already introduced a bunch of events within extended events in order to understand any kind of problem or performance impacts or whatever when it comes to the vector search engine. So that means you have the full control because you can monitor everything with regards to the vector search engine within SQL Server already, which is good. So let's go down. Yeah. Here the first time we will see a vector index. You can create a vector index in this way. Let me go down. I will execute this example here. It's a lot. I think I can split it. Yeah. Okay, so what we can do is the following. In order to use vector indexes, you have to enable specific trace flags. So the first trace flag is 466, the other one is 474, the other one is, you can see it here. Yeah? So there are specific trace flags you have to enable because otherwise you cannot use in the vector index. So let me do this. It needs a profile in this example. That's definitely fine. So what we now can do is we can create a vector index and you can see how it works. So we create the vector index, we give it a name on a table, and then for sure we have to use the vector data type. And now we have to say the metrics. The metrics is again the algorithm we want to use. In this case, it's Cuisine. So then we have I'm just aware of one type, which is disk ANN. We can define the number of maximum degree of probabilism, which is used to create the index. Because you can imagine that when you have a big table, creating a vector index takes time. It really takes time. So I hope that the index is still in place, because you can see it takes more than a minute to create the vector index on just a small table. So when you have this in place, we can easily, yes, let me go down. I think, yes, this is just about the creation of the vector index. I don't want to go into detail because we are missing time. But now we should see the following. Once the vector index is in place, we can now use a function which is called vector search. Within the vector search, we have to name the table. We have to name the column where we will find the embedding and where we use the index. And then we can use the similar to, which is nothing else than our embedding we are searching for. And then we can say, or we can define the number of records we want to get back. So in this, sorry, I've got to include the variables here. Let me go to the execution plan. Execution plan is on. Perfect. Cannot find it. Okay, I need to run it. Sorry for this. I was hoping that the index is still in place, but it should work within a minute or whatever. Yes. So, okay, this will take roughly a minute. I just want to show you the impact of the parallelism. So, as mentioned already, you can define the maximum degree of parallelism. That means the number of threads which are now used to create the vector index. So I'm currently using 8, but you can imagine that it has a high CPU impact. That means it will take a minute, but 8 threads are completely allocated by just creating the vector index. When you don't want to have a very high CPU usage by creating a vector index or rebuilding a vector index, you can define the maximum degree of parallelism. You can say, I don't want to run it in parallel. I want to run it in a serial mode. Then you can say maximum degree of parallelism, and it is set to 1. The impact on the time it takes is nothing, or the other way around. It's a complete different story. It's not just 1 minute anymore. Instead, we have, 5 minutes, right? Now more than 6 minutes, almost 6 minutes, when you run the process in serial to avoid CPU power. So that is the drawback. Yeah? You can decide if you want to run it in parallel or in a serial mode or something in between. You can say, I want to go with 4 or whatever. So when we now use or we run the query another time, that one, so it means we are still using help me to find good Thai food as the query embedding we are searching for. And now I'm running this query. So we have a complete different execution plan. It looks like this. We have here, we can see it. We have a clustered index scan on the table, and we have somewhere here, we have an index scan on our vector data type. And this has complete different impact on the engine than scanning the entire table. You remember the very first example where we don't have an index in place. Again, this was not scaling. The more records we have within the table, the longer it takes. Here, this is the first time that we benefit from the vector index. So that means Microsoft already introduced vector indexes in the latest release and SQL database as well. And again, the problem is that this index is read-only. That means when we now want to insert a new record into the table, it will throw an error because the index is read-only. And now you understand that this has a big impact, because the only way to get rid of it or to update the embeddings, or maybe you want to create new embeddings for the records you're going to insert, is to drop the index and to recreate the index. But you can see it already takes a minute, with 8 threads to calculate all the embeddings for a table. Let me count the table as a number of records. Oops. So we have just 10,000 records, and it took a minute to create a vector index with 8 threads. With 1 thread, it will take you 6 minutes. And now you understand the problem when you have an OTP system and you regularly want to update your embeddings. It works, but it has a very, very high impact on your CPU. Okay, so I don't want to run the examples. I just want to make you aware that you can, for sure, combine full text index with your vector search. That means you can imagine the following. We have a table, the table you already know, and now we are looking for good restaurants. So what you can do now is, first of all, you can create a full text index on all your reviews. And when you have a full text index in place, we can easily use something like this query here, where contains combined is the text in the review, and we are looking for any text which contains restaurant. So that means now we have the full power of the full text engine, which is definitely very fast. And within the result, we are now looking for all the similarities. That means by using the full text index, we can already reduce the number of records. And now we can use the vector search engine on the result of the full text search engine. So that makes it very, very fast because we can benefit from the full text engine or the full text index. And afterwards, we will look for the vector embeddings or the similarity within the result. So that is the idea. So you can easily combine full text index with vector search to get the full power of both features. I think that's it. Do you have any questions?
Okay. A quick look. Okay, Kelly's had to drop off. She had a client meeting. Outside of that, I don't believe we've got any questions so far. If anybody does have any questions, feel free to come off of mute and you can put your hand up and we'll work through who has a question first. No questions? Who's actually thinking about, I know SQL Server 2025 is, going to drop sometime between now and the end of the year. Who is already fast tracking doing an upgrade to 2025 and therefore allowing you to utilize vector search in your environment?
Yeah,
nobody's looking at going to 2025. Okay.
Yeah, interesting.
I guess unless you're already, if you're on the pre-release program where you start to get a look at it, might want to wait until it's actually out, then start to have a look at it and work out where that fits with your cycle of upgrades. But no, thank you, Torsten. A very interesting topic that brings this into SQL Server itself. Do you think that with what you've been playing with, that this will be a bit of a game changer for people on how they're going to be using this?
I think so, yes, because I know a lot of companies. Think about eBay, for example. I don't know whether eBay is using SQL Server 2025 for sure, but you can imagine that other companies has the same requirements. So I know that it is very, how can I say, very different to describe products, right? So to tag products. And what you can do now is for sure you can, when you already have a database of products available, you can easily search within your products for similarity, and you can reuse the same tags in order to find the right group for your products, right? Because someone is using, think about, I don't know, Amazon, where you can look for specific product groups, right? And it takes a lot of time to find or to set the right groups for new products. And with OpenAI search engine, you can easily search for existing products and use the same product groups to be consistent and save a lot of time. That is maybe one example.
Okay. So I guess for everybody here on the call, it'll be a watch this space on when SQL Server 2025 does drop, and based on what you actually do in your environment. So look, I think we'll start to see a lot more of this coming into the market and people using it once it's actually generally available for everybody. So if nobody else has any questions, I'd like to say a big thank you to Torsten for getting up really early, his time, to present for us and share his knowledge on vector search and what is coming in 2025. Muchly appreciated. The session has been recorded. So Torsten, what I'll do is I'll share it with you, and you can then make a decision as to how you want to go with the recording, and we can go from there. So
yes, that's a good idea. That's a good idea. I need to think about it. But what I will definitely will do is, how can I share the code with you?
If you email, because that'll be the notebook.
Yes, that's a notebook. No, I cannot upload the session or the text document here. No, but I can email. That works definitely. Mm-hmm.
Yeah, if you email that through to me, then I can make that available to the attendees.
Yeah, that's a good idea. Okay, cool.
Ray, impressed with good combination of indexing non-vectors to shortlist relevant vectors and using vector constants for desired similarities. Yeah. Thank you, Ray, for the feedback.
That's all great. Very good. Won't do it in my real world, but nevertheless, good.
Yeah, let's see. I mean, it's already available because you were asking about 2025. So who's using 2025? Yeah, not many, but I mean the same features available for sure in Azure SQL database. So therefore you can already use the feature there if you want. Yeah. I don't know how many people are using Azure SQL database, for example. I have no idea. I'm using it. So that means this feature is already available there.
Okay. All right. Well, thank you, everybody. Thank you, Torsten. And
Welcome.
We will look at getting next month's session up shortly and look forward to hosting you all next month. Thank you all. Have a fantastic rest of July.
Yeah, thanks, Warwick. Thanks, Torsten.
Welcome. Bye-bye.